Okay, we're gonna do the best we can with the screen share. It's been going on the fritz lately. Get the student. Hopefully these settings, get it to behave a little bit better. All right, scholars. No major announcements. We are entering the home stretch. We have 3 full weeks remaining, right? So we have not even 3 full weeks. It's not even true. We have this week that's full, right? So this is the last of the new material. Today we're going to be going through section 6.4, systems of equations in 2 variables. Next week, I still haven't checked it, but I'm pretty sure we only meet on Monday, and then that Wednesday is a holiday. We're off for the Thanksgiving holiday. That's usually what it's been the whole time I've been with this institution. And then we come back after the Thanksgiving holiday. That's the final week, right? So we meet that Monday and Wednesday. That Wednesday after Thanksgiving is the last day of class. That Thursday and Friday should be a reading period, even though we don't meet on Thursday or Friday. But, for all of your classes, you shouldn't be meeting on that Thursday and Friday. Then the week after that is the final exam week, right? So your final exam should become available that Sunday. I think it's whatever that Sunday is before the week of finals. It's like the 4th or the 3rd, one of those days. It should become available that Sunday morning at 11 a.m. But what that means is that we're rapidly approaching that hard deadline of Friday, December 9th at 11:59 p.m. Once we hit Friday, December 9th at 11:59 p.m., everything locks out, right? So there you can't submit your final exam late. You just want to, the recommendation is get your things on Pearson in order. When you're done with your final exam, that should be it. You shouldn't be trying to do other things after the final. So like right now is a good time. If you are trying to improve your overall grade, you definitely want to prioritize your old exams. That's where you're going to get the most bang for your buck, right? So you get those in order. You still get unlimited attempts. You can earn up to 90% on those assignments, right? And then after you've gotten your exams, wherever it is you want them to be with those restrictions or stipulations, the last thing that I would prioritize is the old homework. I don't want you to stress too much about the old homework. That's going to be a lot of work for a little bit of points, all right? So it's not really going to shift your grade that much. The homework is really there more so for practice for you, so you can be, positioning yourself for the exam. As far as the final exam is concerned, what we've been doing for the past about year or so throughout the pandemic, they just let me be responsible for my own final, right? Once upon a time, there was a common final. With the pandemic and being remote, I think they just been letting the professors do their own finals. So for me, it's basically cumulative, right? So it's just a little bit of everything from the beginning to the end. You still get unlimited attempts for about 5.5 days, right? I can't think of anything else, any other pertinent information there. Let me see. Let me get these. Oh, that's interesting. Give me just a moment. Oh, shyster. I don't know which one I just let in. I got to go through my list of students now. It'll become available. The exam will become available that Sunday, right before the final exam week, right? And it'll be available for about 5.5 days. I got to see who I just let in because let me see. I got to find them. Okay, I found them. Okay, I think that's the only one. Okay. Yeah, that was good. Okay, yeah, these are good questions. Okay, go back to sharing my screen. Oh yeah, let me watch the stream here as well, because that helps me to see what's getting through and what's not. And then like this, come on. All right. So again, if you have questions, feel free to either unmute yourself to get my attention. That's my recommendation, or you can also type in the chat. I do check the chat periodically, right? So let's get the party started again. This is the last of the new material. I'm just gonna go with it for wherever it is. Okay. All right. And so again, we'll do what we can together right now, and then whatever we don't finish together, you know how it goes. This is the last. If you don't know by now, then but this is the last of the new material, right? So I do have pre-recorded lectures on this. I just do this live session just to fill the air. But the intent is for this to be office hours, okay? So Guess it seems like it's working. Maybe, maybe not. Can you guys see my screen? Or it should say 6.4.
We can't see 6.4. It just says you're sharing screen.
Are you able to see like the objectives 1, 2, 3, 4, 5?
No, it's just in like a Zoom homepage.
All right, let me see. Yeah, I don't. Let me get these guys. It's this one. Let's see. I wonder if there's another way. Because it doesn't pop up here. It's not that one. It's none of those. This is what I need. Let's see. Oh, you know what? Sometimes if I reboot. Okay, that's fine. Let's try this again. Optimize for video. Yeah, maybe it's this thing. I'm just trying to get to the bottom of like, I don't understand why the screen has been acting up. Let me reboot this. Sometimes that'll fix it. But I'm not seeing anything. I'm not getting any signs of life. Yeah, gentlemen, if it's not, maybe if I turn this on, maybe that might be what it is. Because it's, I don't know. We'll go like this. Maybe that might change it. Start the broadcast. And it still says that we're live. Like I just don't know why it's not showing my screen. Okay, I see that one. Let's try now. Are y'all able to see my screen at all? With the objectives?
Now with the objectives, it's still showing something from Zoom.
No, we can't see it.
Okay. What else could I do? Maybe if I turn this off. Screen. Start the broadcast. Ho, ho, ho. Yeah, I don't know. I might have to. I don't know why it's not. I think it was like the update because I haven't really changed anything. Okay, see now that's showing. So then if I click this, let me see if that pops up. Yeah, that's showing. Okay. Let me just start it. Let me go for a few minutes and see. Maybe there's just a lag or something. Let me try this. View seamless. Okay, if I see it in my stream, okay, I'm gonna go with it because I can see it in the stream now. I don't know why. Maybe it's just seamless to single. Anyway, let's just go with it. You know, just you have to get my attention if the image goes away because I don't know why it's not showing. It was or was not showing, but anyway, because I don't change any settings. But anyway, okay. So we're here with section 6.4, system of equations in two variables, right? So some objectives here, we like to verify a solution to a system of equations, solve a system of equations by the graphical method, solve a system of equations by the substitution method, solve a system of equations by the elimination method, and solve apply problems by solving a system of equations, okay? So we have some definitions. A set of equations with common variables is called a system of equations. If each equation is linear, then it is a system of linear equations. Is there like a lag or something? If at least one equation is nonlinear, then it is called a nonlinear system of equations. Here's a system of two linear equations and two variables, right? So we have like two main techniques that we have for solving something of this nature. Let's just kind of keep going. We see a system of equations is sometimes referred to as a set of simultaneous equations. A solution of a system of equations in two variables x and y is an ordered pair of numbers a and b, such that when x is replaced by a and y is replaced by b, all resulting equations of the system are true. The solution set of a system of equations is the set of all solutions of the system, right? We're going to see this in just a moment. So we want to verify that the ordered pair of 3, 1 is a solution of the system. So basically, you know, when x is 3 and y is 1, it should make all equations true. All right, so then let's see. So, you know, if we just substitute 2 times 3 minus 1, what is that? 6. 6 minus 1 equals 5. That one checks out. And then 3 plus 2 times 1, which is 5, and that one checks out as well. All right, so then that's how you verify that the ordered pair of 3, 1 is a solution to this system. In a graphical sense, if you were to look at these two graphs, these are both lines. These two lines should cross at the ordered pair of 3, 1, right? So that what they have in common is going to be the ordered pair of 3, 1. Okay, and here's a type version of what we just did. So then we actually use the graphical method to solve. Oh, so graph, okay. We need some graph paper. So let me do a text box. Let's see. That is fine. And then paper, graph paper, that should be fine. And we'll just work with the space that we have. Let's see. So first, anybody got a favorite color? Let's do equation 1 in green, right? So I'm gonna solve for y in equation 1. So if we add and subtract, we're gonna get y equals 2x minus 4, right? If I solve for y in equation 2, let's do that one in, let's do purple, I guess. Subtract and divide, we're gonna get y equals so negative 2 by 3x. So divided by 3 is 4. Okay. Let's see. So we have a negative 4, positive 4, a negative slope, and a positive slope. So down there, positive, up there, negative. Okay. So then let's start with like the origin about here. And then we basically need to capture plus or minus 4. And then, you know, I think we're kind of working on the right-hand side. So I'm gonna go like this. Okay. And we'll let this be the positive x, and we'll go 1, 2, 3, 4, 5, 6, 7. That should be enough. And then we'll go like this. Okay. This will be our positive y in this direction. 1, 2, 3, 4. We need to get to at least 4. 1, 2, 3, 4, 5. Okay. Here's our origin. We got 1, 2, 3, 4, 5, 6, 7, 8. If we need more, we'll get some more. Then we went 1, 2, 3, 4, 5. Negatives and negatives. Okay. So the first one, the y-intercept is -4. So we'll put a point at the y-intercept. The slope is 2. So we can go up 2 and over 1, up 2 and over 1, right? Goes off the chart. So right about here. So then, all right. Okay. Basically something like that. That's the green one. And then the purple one, the y-intercept is +4 with a slope of a -2/3. So down 2 and over 3. Looks like it's here. All right. Down 2 and over 3 is here. Down 2, 7, 8, 9 would be here. Right. So then connect this with a straight edge. You get something like that. And shorten this to that point. Okay. Cool. All right. So then you can clearly see that they cross at. So then this tells us that the solution to the system is the order pair 3, 2. Right. So that's where the two graphs cross. So that's the points that they have in common. So then the order pair 3, 2 should work in both equations. All right, should make both of them true. Let's copy. And then we'll just do a quick check. Let me undo. I was able to move that other one. There we go. Is that distorting the whole thing? Let's see. Let's go paper. That's fine. And then just to do a quick check. Okay. So then 2 times 3 minus 2. What is that? 6 minus 2. 4. That one checks out. And then let's kind of go over here. 2 times 3 plus 3 times 2. 6 plus 6 is 12. That one checks out as well. Okay. So I feel like that one's pretty clear. So in a graphical sense where the two graphs cross, that's going to be the solution to the system. That's going to be the points that make both of them true. Okay. So they did something similar. They graphed the two on the same coordinate plane. You know, it's a type version of what we just did. Okay. Let me see my time. Cool. So the solution set of a system, let's go like this. That's fine. The solution set of a system of two linear equations and two variables can be classified in one of the following ways. Let me check on you guys in Zoom. What's the time? Yeah, let me check on you guys. So let me get the student. This one. This one. green. Oh, yeah. I told you the best way to get my attention is Audible, because it's just it doesn't give me notifications for the chat. So that's a more of a delay. Hopefully they didn't mess stuff up. We're just gonna go with it. Okay, so I think it's okay. Again, the solutions to a system of equations can be classified in one of the following ways. One option is that we might have just one solution like we've seen so far. The system, we said that this system is consistent and the equations are said to be independent, right? Okay. Then here's an example where we have no solutions. That means we have parallel lines, and we say that this system is inconsistent, all right? So when there's no solution, we say that the system is inconsistent. And then lastly, we have infinitely many solutions. That's where the one line lays on top of each other. Usually like one equation is a multiple of the other. The system is consistent and the equations are said to be dependent, right? Usually, again, that appears as one equation is a multiple of the other, okay? Infinitely many solutions. We say the system is consistent and the system is consistent and the equations are said to be dependent, okay? So we're asked to solve this system. We could do graphical. I think I just want to launch into one of our techniques. Let me see, do I want to graph this? I don't really want to graph it just because graphing is kind of tedious. All right, so I'm going to go ahead and introduce the elimination method, right? Well, actually, this one looks like it'll be easier to do the substitution. So we have two more techniques that we need to talk about. I'm going to go ahead and introduce the substitution method here, right? So another technique that, aside from graphing, another technique that we have for solving a system, one of them is called the substitution method, right? Where you solve for one variable in one equation, then you take that and substitute it into the other one, right? So this one, it seems like it would be simplest to solve for y in equation 2. All right, if we solve for y, right, add the 2x to both sides. So from equation 2, we quickly get that y equals 2x plus 9, right? So then we can take this y and plug it into the other equation, right? So when you're working systems like this, every time you have an unknown, you need an equation. We have two unknowns that we're solving for, so that's why we have two equations. If we had three unknowns, we would need three equations, so on and so on and so on. Generally, that's how that goes. There are some exceptions to that, but that's generally how that goes. So let's take this and plug it into equation 1, and we'll have 2x minus 5 times y equals 3, but our y in this case is going to be 2x plus 9, okay? Thank you. Stop. Okay, so then now we have one equation, one unknown. Now we're ready to solve, okay? So then we can distribute this -5. Then we'll have 2x minus 10x minus 45 equals 3. Let's see. I want to add, let me see, because we're going to get what, -8x? I want to add 8x to both sides. So we'll get 8x equals, what is that, -48. So then x equals -6, right? So then if this is our x, we take this and plug it into either of the other equations. I want to plug it into equation 2, okay? So then that's what, y plus 12 equals 9. So then y equals -3. So then our claim that the solution to the system is going to be -6, -3. Okay. So then we just need to confirm that this indeed works. Let's copy that. That's fine. All right. So -6 times 2 is -12, plus 15 is indeed 3. -6 plus, wait a minute. 3 times 2 is 6. That's a 0, right? Maybe we did something wrong. So you add, you get that. Oh, y. Okay, okay. Y is -3, right? So then -3 plus 12, 12 minus 3 is indeed 9. It checks out. When I was checking it, I had plugged the x here and the y here and it wasn't working. I was like, what did I do wrong? I did the wrong improper substitution, but yeah. So this checks out. Okay. guys have any questions? Let me see. Actually, you know what? I don't want to touch it because it's been so temperamental. Okay, so let's keep going. And here's a type version of what we did. So yeah, they did the same technique that we did. They did the substitution where they solved for y in equation 2 and then plugged it back into equation 1. And then they basically did the exact same thing that we did. Okay. Okay. So let's give this one a go. We're asked to solve the system of equations. Okay. I mean, that's fine. We can do the same thing. Yeah, let's just do the same thing. Well, here, let me just take this as an opportunity to just go ahead and introduce the other technique. So we just did an example on the substitution method. The other technique that I wanted to showcase is called the elimination method. With the elimination method, what you do is you choose one of the equations. You want to multiply one of the equations so that one variable has the exact same number, is the exact same, just has opposite signs, right? So this one is a little bit different. Let me just start by getting a copy. We have x plus y equals 3, and we have 2x plus 2y equals 9, right? So with the elimination technique, like if we multiply the equation 1 by -2, so we're basically going to like distribute a -2 across the row. This is going to be a -2, that's a -2, and that's going to become a -6. All right, we're multiplying. But then you'll notice something happens. Now that you have at least one variable that's the same but with opposite signs, you would add the two equations together, and that one would cancel. But then what happens here on the left, we're going to get 0 equals 3, which is false, right? So this is a special case because both variables canceled, right? They both canceled, and we finished with a false statement. So that implies that this is inconsistent and the lines are parallel. So we're going to just say no solution. We should be working with parallel lines here, right? Let's see what else we got coming. Or it's inconsistent, you know, something of that nature. Right, and so then they were using the substitution method. They solve for y. When you plug it in, they finish with that same false statement. So that implies that we have two lines that are parallel to each other. Okay, let me see the time. Okay. So then solve the system of equations. Okay, so let's try to do. Oh, this is it. Okay. Well, even if we did elimination method again, right? This is another special case, so we're not really getting a good example for elimination yet. 4x plus 2y equals 12, and then we have this -2x minus y equals -6. Right? So then notice if we multiply the second equation by -2, so we're going to distribute this -2 across the entire row. Okay. The first row just stays as is. But then the second row becomes 4x plus 2y equals 12. And then when you go to subtract, right, when you distribute, we probably should have multiplied, instead of multiplying by -2, we should have just multiplied by +2. Yeah, let me just make that change. If we had multiplied by +2, then we would have gotten negative here, negative and negative. And then we're ready to add the equations together and we finish with 0 equals 0. Notice that this is true. So because all the variables cancel and we finish with the true statement, that means that the system is consistent and the equations are dependent, right? So we have infinitely many solutions, and the solutions are going to take on the form, all the ordered pairs are going to take on the form, for any x that we choose, y is going to be, add, -2x plus 6, negative 2x plus 6, all right? So any x we choose, the corresponding y is going to be negative 2x plus 6. And all I did, I just solved for y from here, added y, added my 6, and I got this guy. So that means that no matter what x we choose, the y is going to take on this form. And that's going to be our solution there. Okay. If anything is not clear, feel free to unmute yourself to get my attention and we can talk about it. Okay. All right. Let's see what else we got. Let's see if we can get a good one for elimination method. All right. So these are dependent. We finished with the true statement. So then one equation is a multiple of the other. All the x's are going to take on the form. All the ordered pair, all the solutions to this system are going to take on the form x, comma, and we wrote it as negative 2x plus 6, right? I think we get the same thing. All right, so now let's see. This might be a good one to solve. Yeah, elimination method, right? So we want to pick a variable to cancel. They both seem about to have the same level of difficulty, so I'm just going to cancel the x, right? If I'm going to cancel x, what I want to do, I want to multiply. Let's multiply equation 1 by 3. All right, so we're going to distribute a 3 across here. And then let's multiply equation 2 by negative 2. So we're going to distribute a negative 2 across here, okay? So then if we do that, the first equation is going to become, we're going to have 6x plus 9y equals 63, okay? And then the second equation by negative 2 is going to give us negative 6x plus 8y equals negative 46. Okay. So remember our goal, we were focused on the x, right? The goal was to get x to be the same, to have the same coefficient with opposite signs, right? So now when we add the two equations together, a number plus its opposite adds to 0. Okay. 16, 17, right? So 9 plus 8 is 17. Y equals, let's see if that were 50. 13 plus 4 is 17. So then y equals 1. Okay. So we got that y equals 1. So then we want to take this and plug it into either equation and solve for the other variable. I think I'm going to choose equation 1. So when y is 1, that's going to be a 3. We subtract the 3, we get what, 18? So we'll have 2x equals 18. So then that gives us that x equals 9. Right, I'm just kind of running out of space. So that's what I was kind of. So then the order pair, our claim is that the solution to the system is going to be 9, 1. All right. And then we just want to verify that this ordered pair works. Okay. So 18 plus 3 is 21. 27 minus 4 is what, 23. All right. So it works in both equations. Okay. Hopefully that's okay. All right. So then we have a type version. Now it looks like now we chose to eliminate x first. It looks like they chose to eliminate y first, and it's fine. It's, you know, it's more than one way to, you know, get to Snow Mountain from here. So they chose to eliminate y. They got x is 9. I think they got the same thing that we got, right? 9 and 1. Okay. And then you can see where they check. So it's a type version of everything that we discussed. All right. So we've seen demos on the substitution method where you solve for one variable and then plug it into the other equation. We saw elimination technique where you choose a variable to eliminate and you want it to be this to have the same coefficient with opposite signs. Then you add the two equations together, and then, you know. So now this is another type of substitution called linearizing substitution, right? So in this form, you know, it can be kind of a challenge. I think I might need some more space. Let me give myself some space. Let me add a page here. Then let me change the view to seamless. Cool. Okay. So with this, we want to do a substitution to make it, we're going to change the form just to make it easier for us to solve, you know, and let's kind of go forward like that, right? So we're gonna, let's let u be 1 over x, and we're gonna let v be 1 over y, okay? So then if we let u be 1 over x and v be 1 over y, then that changes our system into the form 2u plus 5v equals -5, and we have 3u minus 2v equals -17. So that's, this technique is called linearizing substitution, right? I think, hopefully I'm saying that properly. Okay, so we basically change or transform the shape of it into a system of linear equations. Before, you know, that's going to be more of a challenge to try to solve that. This is much simpler, much more simple to solve, right? So then in this form, now if we just invoke one of the techniques that we had before, I think I'm going to cancel out my u. I feel like that might be a little bit easier than the v. I'm just choosing a variable to eliminate. So now if I'm focused on my u, again, I want those to have the same coefficient with opposite signs. I'm going to multiply the first equation by what, 3? So I'm going to multiply by 3 across the entire row. And I'm going to multiply the second equation by -2 across the entire row. Okay. So then the first equation becomes 6u plus 15v equals -15. And the second equation becomes -6u, okay, plus 4v, 34. Okay. Now when we add the two equations together, the first term adds 0. Number plus its opposite adds 0. 15 plus 4 is 19v. If that were 20, that would be 14. So that's 19. Yeah, 19. So then we got lucky here, v equals 1. Okay. So then we can take this and plug it into either equation. I'm going to plug it into the second equation. So then we'll have 3u minus 2 equals -17. So then 3u equals -15, u equals -5, okay? So then we want to take these results and plug it back, right? So if u equals -5, and let me highlight these guys. So we got this, okay? If u equals -5 and u was 1 over x, so then that means that 1 over x equals -5. So then if you basically solve, you can like cross multiply here. X equals a -1/5, okay? And then we also got that v equals 1, and so that means 1/y equals 1. If you flip both or you cross multiply, then y equals 1. Okay. So then our claim is that the solution, the order pair, that's the solution to the system is going to be a -1/5, 1. Okay. Okay. What's the time? Well, the time totally got away from me. I just want to check this. Let me copy. And to check it, let me see. Okay, I was going to use a calculator, but I think doing this by hand might be a little bit more simple. I think there is a way to do it with the 83 plus. I had to think about it for a little bit though. But if I just plug it in, 2 divided by a -1/5 becomes what? -10 plus 5 equals -5. That one checks out. And then the second equation, the first term becomes -15 minus 2 is indeed negative 17. That one checks out as well. Okay. So we still have about a little under 10 slides remaining, but that's essentially time. I do want to stop there. If you want to see the remainder of this, I would check out my pre-recorded videos, my pre-recorded lecture. Did you guys have any questions while I make a copy of this available? All right, so I am making a copy of everything that you saw me writing. I'm making a copy available on Blackboard. When this bar finishes loading, you'll get a copy. And if there aren't any burning questions, we're going to end the session here. And from one beautiful mind to another, enjoy the rest of your day, guys. Take care. Peace.